Okay, so let's look at the theorems. The first theorem, area of a triangle. Oh, sorry, area of triangle. So the theorem says for any triangle, base times height does not depend on the choice of the base. Okay, but what's really important here is the formula to calculate the area of a triangle is that the area of a triangle is half the chosen base multiplied by the height that's perpendicular to the base. Okay, so if we choose to the base as BC in our calculation, we can only choose a height in the equation that's perpendicular to that base. If we chose this as our base, we would have to find a height that was perpendicular to the base AB. Okay, so it's like in this example here, we have the triangle A, B, C. The area of this triangle, or the area of this triangle here for this calculation is AB multiplied by this perpendicular height. This height that's at a right angle to AB. We can't choose this base AB and multiply it by a height here if we were given the height. Okay, we'll see it come to an example in a while. The second theorem is to do with the area of a parallelogram, and this is saying that the first thing it says actually is that the diagonal of a parallelogram bisects the area. So in other words, if we have a diagonal go from D to B, then the area of the parallelogram is halved. So that must mean that the area of this triangle is equal to the area of this triangle here. ADB is equal to DCB, and that's used in some calculations. Okay. And then the main part of the theorem is that the area of a parallelogram is the base multiplied by the perpendicular height, i.e. if you choose this base, you can only multiply that to find the area. Area equals base by h. You can only use a h, a height, that's at 90 degrees or perpendicular to the base that you choose. Okay, so if you were to use in another example, say this base AD, you would have to find or use a height that was perpendicular at 90 to AD. Okay, and for all of these, I tell you what, you can see here that there's examples in the book that you can refer to if you need to. And it's just something to just note as well that when we have a parallelogram, you know, when we draw the parallelogram, if we were to continue the lines through, then we have parallel lines and transversals. So that means that a lot of the rules to do with corresponding angles would hold. Okay, so it's just something to be aware of. It's good in geometry to try and visualize the shapes that come off the page. The third theorem is to do with triangles and ratios. So if we look at the third theorem here, at the angle opposite the greater of two sides, if we take this side and this side, is greater than the angle opposite the lesser side. So the angle of 100 is greater than the angle of 50. The angle opposite the longer the two sides is greater than the other angle. And I suppose the opposite to this, or the converse of this theorem, is that the side opposite the greater of two angles, this side is opposite the greater of, say, these two angles, is longer than the side opposite the lesser angle. So here 5 is longer than 2.5. And you can find examples and problems in the book. The fourth theorem is to do with triangles and inequality. And basically, the fourth theorem just states that two sides of a triangle are together greater in length than the third side. Okay, and really, you know, the shortest distance between 2 points, the shortest distance between the points B and C, or any 2 points, is the shortest distance is always the line joining them. That's the shortest distance. It's obviously not all the way to there and all the way around to there. That's the long way around via A from B to C. And that's kind of what this theorem is saying, really, that this side will always be less than the sum of the other two sides, or this side will always be less than the sum of this side plus this side. So it's kind of obvious enough, that one. And just as we have it mentioned here on the page, the whole notion of congruent triangles, congruency, congruent triangles are the same size and shape, and they will two triangles will always be congruent if they have three sides the same length, or they have the same angle size between two sides of the same length, or they have the same length of a side of one of the. Both triangles have a side of a particular length that's between two angles of the same side, or finally the two triangles can be congruent if they both have a right angle, same length hypotenuse, and one other side the same length. The fifth theorem is to do with transversals and parallel lines. Okay, so if we have three parallel lines, L, M, and N, the theorem states that three parallel lines, L, M, and N, cut off equal segments on some transversal line, like this P, equal length AB is equal to BC, or there's another transversal here, Q, where DE is equal to EF. So then they will cut off equal segments on any other transversal. So what this theorem is saying essentially is, if this transversal cuts through the three parallel lines and creates a segment here equal to this segment here, so this segment is equal to this segment, then if I was to cut another, or put another transversal through the three lines, Z, then that would make this segment, whatever it is, equal to this segment here. And if I was to go through there like that, then this segment in length would be equal to this segment in length. That's not to say that if this was 5, that this one is now 5. It's not saying that. It's just saying that if a transversal makes this section equal to this in length, then any other transversal will make this one equal the other one. But it's not to say it's the same length as the original. The sixth theorem says that a line parallel to the side of a triangle, or to concern itself, with a line parallel to the side of a triangle. So a line drawn parallel to one side of a triangle, so this line here parallel to this side of the triangle, divides the other two sides, that's this side and this side, in the same ratio. So in other words, if we draw a line parallel through the triangle, then this length over this length is equal to this length over that length. That's what we mean by the same ratio. And solving that one there, we can see that this length x is 2 2/3. Really, this theorem here is an extension of this theorem, because if I just come down here, if I have two parallel lines and I have a transversal, okay, if I have three parallel lines and I have a transversal T, and it cuts this so that this side is equal to this side. If I put another transversal through here, I actually, from this theorem here, that means that this is the same as this side. So if that was length A, B, C, D, then what I have here actually is a triangle with two parallel lines, and AB is the same as C over D. The seventh theorem is to do with similar triangles, okay? So triangles are similar when they're the same shape, but they're different sizes. And really the situation with similar triangles is that they are known as being equiangular. In other words, two angles or more are the same. So here with two triangles, we've an angle of 70, an angle of 70, an angle of 50, and an angle of 50. These are similar triangles. If two out of the three angles are the same, the third one must be the same as well. Okay, so we have two similar triangles here, ABC and DEF. And basically, if two triangles, ABC and DEF, are similar, then their sides are proportional in this order, given here. And what's that saying is, for this theorem, we have to look for what's known as the corresponding sides, okay? And the corresponding sides are those sides that are opposite the same angles. So, AB is opposite 60 here. That corresponds with this side here, because that's opposite 60. DE, okay? AC is corresponding to this side, because they're both opposite 50. And finally, BC corresponds to C, EF, this side, because they're both opposite 70. And knowing the corresponding sides, AB over DE, the length of those is equal to BC over its corresponding side, EF, which is equal to the length AC over its corresponding side, DF. And when you come to see problems with these, you'll see that you'll be given, you know the length of, say, 3 sides, and you have to find the fourth using some part of the correspondence.